Hey guys, welcome to our video about relations and functions. So we're talking about relations, and let's recall that relations are any set of ordered pairs. Right, so ordered pairs, if we're talking about ordered pairs, we're talking about coordinates x and y, right? And if it's a function, we've got an input and an output, right? So this input and output are what define a function, right? And so we talk about functions as every input has one output only, right? And so we've talked about it in terms of x's and y's, right? And so we talk about how the x's don't repeat for functions, yes? So within functions, right, we've got lots of different functions. And so if we're trying to identify functions from a graph, right, recall that we've got that special test with the vertical lines, the vertical line test. So that says, right, that if we're looking at a graph on a coordinate plane, and we see something like this continuous graph, recall that if we're talking about the vertical line test, if we place a vertical line anywhere on our graph, that vertical line should touch the graph only once. Yes? So we've got functions that pass the vertical line test, and we've got other kinds of graphs, right, that don't meet that. So graphs that look like this, or graphs that look like this, are sideways parabola. Oops. Right, or circles. Circles can't be functions. We can even see that in the y-axis. It touches that y-axis 2 times. Or if we have graphs that look like this, right? So we've got these different kinds of graphs that are still graphs, right? They're still relations. They contain sets of ordered pairs, but they don't pass that vertical line test. So they're outside of being a function. So the big functions that we talk about are these linear functions, right? These straight lines. And within those linear functions, we've got 2 big categories. We've got this direct variation category, where all of these direct variation graphs go through the origin. They intersect at x equals 0 and at y equals 0. And we write that like with the mx, right? Because we have a slope, but there's no y-intercept. And we also write it like that equation. This being the constant of variation. So if we've got these proportional relationships as one of our big categories of straight lines, we've got proportional, and so we've got non-proportional. any kind of linear function that has a y-intercept that's not equal to 0. And that's where we get our y equals mx plus b equation. And if we have an input and an output, we can write this equation in function notation, where this is the slope and this is the y-intercept. Now we do have linear functions, linear equations that are outside of being functions, but they're still related to linear functions. And that's when we see these vertical lines. So if I've got a graph on a coordinate plane, this is our y-axis, this is our x-axis, and say that I've got this graph, and we'll make it bold so it doesn't look like the y-axis. It's a continuous relation, right? It would go for infinity, but it doesn't pass that vertical line test, right? It hits this line everywhere. So this cannot be a function, and it only intersects one axis. It intersects the x-axis. So say that this was -2 on the x-axis, we would have x equals -2 as the equation for that line. So we talk about linear functions or functions in general. We talk about them being either continuous, so this is an example of a continuous function, or we've got those discrete functions, those discrete values. And discrete domain and range, input and output, can still be a function because it's a set of ordered pairs that have input and output. We just don't connect those ordered pairs together on the graph. So we could say that these are, connected points for continuous and disconnected points for discrete domain and range. So those values, right, if we were saying that this was the domain, those values that would be in a list as opposed to an inequality. So we would see that the domain, right, for this would be all real numbers, but let's use an example of the range, because I see that my range, we could say that this only goes up to here, right? This goes down here, and we could even say that, just to make it easier, that we've got like a cosine function. And so if this was the lowest point of the y value, this is the highest point of the y value, we could say that y equals 2. Up here, y equals -2. And we talked about how to find the range from these least to greatest values. And y would be greater than -2 and less than or equal to 2. Now in Algebra 2, we'll talk about other kinds of functions. But in Algebra 1, there's only one other big category of functions that we're going to talk about, at least for the time being. So if we look at this other category over here, our next big unit in Algebra 1 is going to cover quadratics, right? Quadratic equations. And quadratic equations look like, in general, look like this shape. So this is the parent function for a quadratic. It goes through the origin, and it's y equals x squared. and that's really important later, but you don't have to worry about it so much right now. The shape that it makes is called a parabola. So, in conclusion, right, we've got lots of different relations. Lots of different relations. Some of them are functions. Some of them aren't functions. Some are related to functions. We look at a lot of linear functions. We've talked about discrete and continuous data. And another big category we'll talk about is quadratics. Thank you so much for watching this video. When you complete these notes, you'll have everything you need to identify relations versus functions. Thank you.